Hi everybody, CBSE students, intermediate students, IIT JEE aspirants and NEET aspirants. Welcome to BMS Academy. My name is Mr. BHANU MOORTHY, Senior Physics Lecturer. This is my own academy and this is my own institution. I'm conducting the classes from my own house. Now this is the video class number 8. I want to present some 2021 questions from Newton laws of motion. Listen carefully. In 2021, from this chapter Newton laws of motion, what type of questions they asked, what type of concepts they asked in 2021. Let us discuss. In previous video class number 7, already I projected some constrained motions, connected bodies, and next contact forces between two blocks. So we discussed all those previous entrance questions in the last video class number 7. Now in this video class number 8, I am presenting Newton laws of motion chapter, the different types of questions they asked in 2021. Now let us quickly move to this now. So this is the first question, rocket propulsion concept. They selected rocket propulsion concept in this 2021 from this chapter. Now actually in rocket combustion gases are there, you know. Combustion gases means this is a fuel. It acts as a fuel, okay. So when the fuel burnt suddenly, what happens? Combustion gases will rush downward direction with greater speed at different variable mass, rate of mass. So combustion gases after burning, they rush in the downward direction and push the earth with greater force. Okay, that is called as action. Action is exerted by the gases on the ground. In reaction, what happens? Ground exerts some upward force on the rocket. This is a reactional force. Based on this concept, Newton's third law concept, they asked this question in 2021. So mass of the rocket is given there. Next, acceleration of rocket is given in the upward direction. Acceleration due to gravity value also mentioned there. Now the gas is combustion after burning. This is a question. At what rate the fuel gas should be burnt so that the rocket moves upward direction with greater acceleration? So once the gas is burnt, it comes down with greater speed at the rate of dm by dt with greater speed. Then the rocket will be moved up. Okay, so this is action reaction concept. They selected this one in 2021 in one of these sessions. Either morning session or afternoon session, I don't know, but they asked this question in 2021. So what is that? As the rocket moves up, its apparent weight increases, you know. So m into g plus a, as the rocket moves up, m into g plus a, its apparent weight increases. That apparent weight provides the necessary force exerted by the jet of the gases in the downward direction. So the gases are coming down with greater speed, that is 500 meters per second. And gas is coming down at the rate 2 kg per second, 3 kg per second, like that. So what is this rate of gases after burning? At what rate this should come down so that rocket moves up? So this is the concept. According to Newton's second law, F equals to ma, no? So this is upward motion, Fm into g plus a. When the rocket moves upwards, apparent weight we can call it as. And this is force exerted by the jet of gases. Velocity into rate of mass. It is also representing one force. Okay. So let us go to, if you substitute all these values in this case, mass, velocity, acceleration, like that, you can calculate dm by dt, rate of mass of the gas. Okay. The next question is law of conservation of linear momentum they selected. They selected law of conservation of linear momentum. We know that this is a rocket bullet gun system. Okay, when the bullet is fired, with a gun, what happens? Bullet moves forward with the greater speed. Mass of the bullet is given 4 grams converted into kg. Next, velocity of bullet is given Okay, so this then momentum of the bullet is mBvB. Okay, now as a result, what happens when the bullet moves forward? Barrel of the gun recoils back and pushes our arm with great force. So that is reactional force. Now here the barrel of the gun having mass m 4 kg given and it moves back. This is called as recoiling velocity. So my students, they asked this question: what is the velocity of the gun? Mass of the bullet given, velocity of the bullet is given, and the mass of the gun is given. He is asking velocity of the gun. Very simple problem they asked in 2021. So momentum of the gun is equal to momentum of the bullet. All values are given there, all parameters are given, and we can calculate what is that? Velocity of the rocket. Right? Very simple question. At the same time, momentum of the velocity of the gun. Momentum of the gun also we can calculate. mg, vg. Once we get vg, we can calculate mg, vg. And my dear students, remember this point. Masses are different, velocities are different for both bullet and gun, but their momenta are same. So the ratio of momenta is same, 1:1. Okay, remember this point. Masses are different, velocities are different, but momenta of gun and momentum bullet both are same. Okay, so this is the question now they asked here. Velocity of the gun they asked, and momentum of the gun also they asked. mg into vg, right? Right. Now let us move to third question in 2021. They selected this question in one of the sessions. What is that? Projectile motion. A body is projected into air with some velocity 5√2 meter per second, with at an angle 45 degrees with the horizontal. Its mass also is given there, 5 grams, converted into kg. Now mass given, velocity is given, and angle of projection is given. Question is what? What is the impulse between A and B? What is the impulse between A and B? My dear students, this is also very important concept. Change in the momentum is called impulse. Change in the momentum. It is a significance of Newton's second law. Second law explains impulse concept, okay? Now, here, this is the momentum mu sin theta it is, and it is after reaching the ground, downward direction, minus mu sin theta. What is the change in the momentum in the vertical direction? So this one minus of minus. Both are in the opposite direction, you know. So change in the momentum is minus of minus. That is plus. So final answer is 2 mu sin theta. So mu sin theta minus of minus mu sin theta becomes 2 mu sin theta. The change in momentum between first point and last point in the case of a projectile is 2 mu sin theta. Okay, and in the horizontal direction, you won't get change in the momentum, because in the horizontal direction, velocity is always constant, no? So if velocity is constant, momentum is constant, there is no change in momentum along x-axis direction in the case of a projectile. But in the case of vertical motion, so change in momentum takes place, so that is minus of minus, that is 2 mu sin theta. So mass is given, you can substitute here, velocity 5√2, you can put here, and sin 45 is 1/√2, you know that, you can get the answer. This is the question they asked in 2021 from this chapter, one of the sessions. Now let us quickly move to fourth question in 2021 from the same chapter. So in different sessions, they are selecting different conceptual models. Okay, so this is one more conceptual model. It is also under impulse concept only. A ball of mass, billiard ball, whatever it may be. So this ball of mass m moves with the velocity v horizontally and strikes a vertical wall normally and comes back with same speed. So moves this direction, normally strikes the wall and comes back. What is the change in momentum? This is mv, this is minus mv, change is nothing but 2 mv, minus of minus. Similar concept, right? Next, in the second case, impulse. In the first case, impulse we got, that is J1. In the second case, the ball is striking the wall at some angle, different angle. Here it is striking at 90 degrees angle. Now it is striking at 45 degrees angle. So then, if it strikes the wall at 45 degrees angle and rebounds at the same angle, rebounds with same angle by making same angle. So then, but we want the change in momentum along the normal direction. So we can resolve that momentum in different components. We can resolve the momentum in two components. This momentum is in this direction, and this momentum is in this direction. So this is mv cos theta, and this is also mv cos theta. Minus of minus becomes a plus. Okay, now just like this concept. So minus of minus becomes plus because they are in opposite direction, along the normal. This is mv cos theta and this is mv minus mv cos theta. So difference is change in the momentum is nothing but impulse, that is 2 mv cos theta, cos 45. Okay, now the question is, what is the ratio of impulses in these two cases? Ratio of impulses. Okay, so J1 by J2 equals to 2 mv divided by 2 mv cos 45, that is root 2:1. Cos 45 is 1 by root 2. So my dear students, IIT main students and NEET students, CBSE students, all intermediate students, it will be applicable to you. So my duty is to project different conceptual models from each and every chapter regarding JEE mains as well as NEET. And your duty is to listen carefully, grasp the concepts from me, okay, and try to get the ranks in your respective entrance examinations. The NTA has not announced this date of examination. Mains examination date is not at all announced by NTA. As soon as possible in this week, most probably they are going to announce this examination date. So be ready, be careful, try to understand all these concepts, and continuously I will project the concepts from different chapters. So this is Newton laws of motion. In video class number 7, video class number 8, I projected number of questions they asked in 2021. Now I am going to project the concepts from the same chapter or different chapter in 2022 also in the next video class. My dear students, you remember one point. In this academy, I am conducting physics classes in the early morning hours and evening hours. Nearly 50 conceptual models I am projecting to the students, those who are listening my classes in the morning hours as well as in the evening hours. So I am conducting tuition classes. If you are interested to listen all those conceptual models from every chapter, then you contact these numbers, and in the early morning hours as well as in the morning hours, anytime, morning hours or evening hours, you can contact to these numbers. And if you want to listen these video classes, you like, share and subscribe these video classes, and don't forget to press the bell button and do viral, make viral these videos to all your friends circle, so that they can gain the subject. Okay, that's all. That is my satisfaction. Okay, so I opened my own institution, and this is my own video channel. Okay, this is my YouTube channel. Okay, my own YouTube channel. So I am projecting video classes to you. Only in physics classes I am projecting. In previous entrance examinations, how they are asking the questions in 2021, 2022. From each and every chapter, I want to project the models, different models, so that you can get awareness on these concepts now. Okay. Otherwise, if you want to listen carefully, if you want to listen all the concepts in detail from each and every chapter, you join in this institution in the morning hours classes and in the evening hours classes, right? See you in the next video class about another chapter, okay, regarding previous entrance examinations. And for NEET students also, these topics are helpful to you. Almost similar concepts they are asking in NEET entrance examination also. In the next video class, I am going to present NEET students as well as JEE mains aspirants. So for those aspirants, I am going to present some other conceptual models from previous entrance examination pattern. Okay, see you as quick as possible. I will come back again. Okay, right. See you. Bye.